Okay, so we're going to move on now into section 3.2, where we're going to talk about continuous and not continuous, if it's linear or nonlinear. Couple things. Let's talk about the differences between this. Continuous means that it's a continuous line. And when we talk about continuous, yeah, it could be a straight line. It could be a line that has starting and stopping points. It can even be things such as so linear means straight, so keep that in mind. So anything that's a straight line that has starting and stopping point, or is going to be just a line in itself. Now, when you talk about discrete, discrete means that they are dots or ordered pairs. They are not graphed. Whoops, and that's not really straight. Sorry about that. So basically, they can draw a straight line, but there isn't one to start out with. So the most important thing about it is in discrete data, it means that they are dots that are in a straight line, or you can look at their slope. So if you look at the dots and you see they have the same rise and run, which we'll be talking about that shortly, if they grow by the same amount all the way up, then it's considered discrete. And it's a linear function because it's making a straight line if I should consider connecting them. So that's what those two terms mean. Now, linear means straight line. I think we pretty much established that already. Nonlinear means not a straight line. It doesn't grow the same. It doesn't have the same slope. So for every X amount change, the Y amount should change the same amount also. So with that being said, let's look at our note packet. In our note packet on page 68, we have some diagrams here. Now, we're not determining whether they are functions or not. That's the first thing you need to realize. We're not asking if they're functions. We're trying to determine if they are linear or nonlinear functions. I think sometimes we get that, we just finished functions, we get that tied together. So let me make it real clear. Linear means straight line. Does it make a straight line? Does it grow the same? If it doesn't, then it's not a linear function. And that's okay. That's just a function, just not the same. So if we look at something like this, that is considered a non-linear. And it's because it's not growing the same. We start off here and here, and then here and here. And if you notice, the growth isn't equal. They start having more of a Y value and the X value goes out. So if you notice, the growth factor is not the same, so therefore it's nonlinear. If you look at number 2, it's a straight line. And it's going right through the origin here. It's kind of a narrow line here. And this one has the same growth factor. That helps if I draw it. So it has the same growth factor. So if you go there and you go across, you will notice that you have the same amount of growth for this particular one. So this is linear because it is a straight line. Now for number 3, we're making a table. And let me number these so that you can see which one I'm talking about. So number 3 is going to be a table. And what we're trying to conclude is if it is linear or nonlinear by looking at the growth. All right. So 1, 2, 3, 4. And down here, I have -1, 2, 5, and 8. So this is a 1-to-1. I add 1, I add 1, I add 1. Okay. This down here, we added 3, add 3, and add 3. If you notice, for each one, they have the same growth factor. So therefore, it is considered linear. Look at number 4. Number 4, we have a nice table. It looks seemingly the same until we start putting in some values of what X and Y stands for. So -1, 0, 1, and 2. So this does grow by 1. Like I said, they always look the same. It's the Y usually that's going to change. And you're going to find as we go throughout the semester, When we start looking second semester into this, we're going to talk about 3 different types. We're going to talk about linear, we're going to talk about exponential, and we're going to talk about quadratic. So it's really important that you pay attention to what this one means, because we will be building off this concept. Now, down here at the bottom, this is by 1, and then this is by 1 again, and then this is by 3. So this one does not grow the same. So this is non-linear. And in all honesty, this was -1, and then that was +1, and then that was 0. And so you also notice you have y being the same amount twice. And that means it is a function, but it's not a linear function. A linear function, each x and y value would be unique to each other. They wouldn't be the same. Okay, so now we're going to look at equations. So there is diagrams, here are tables. Now we're going to get into an actual equation. So y equals 3 minus 2x. All right, first thing we're going to look at how this plays out. If you notice, the exponents on each one is to the first. Yeah, they aren't showing it, but those are invisible ones. So I have y to the first equals 3 minus 2x to the first. So this one is considered linear because it's 1 to 1. Really important you see that, 1 to 1. If they'd had any other exponential amount on there, they would not be considered linear. Doesn't mean they won't be a function, once again, but it just means it's not linear. All right, now number 6. When we look at number 6, we have y equals -3/4. So far we're still good. X to the third. Bam, there's our problem. X to the third still makes it a function. However, it's not linear. So this one's considered non-linear because it is not 1 to 1. If it had been a 1y and a 1x, then it'd be okay. And 1 meaning the exponents, folks. Please remember, we are looking at the exponents when we're making this determination. We will get a lot more into exponents in chapter 6, but right now all I'm asking you to do is compare the exponentials. Okay, and that's the number that is carried in the exponent. So those two there are examples of how to read it in an equation. Now, number 7, this we're going to talk about discrete or continuous, and I kind of already gave this one away in the intro. A discrete means that it's by dots. Continuous literally means it is a line. So this one is considered continuous because it is continuing from this point to this point. There is no break in it. It's one solid line. And number 8 then is going to be an example of a discrete. It is making a straight line. It is growing the same amount. And in the note packet, you'll notice that this right here is 3. This right here is 1. And then let me scoot it over here. This right here is 2. And then this right here is 3. Not great, but you guys get kind of an idea of what is going on. That's 4. And that's 5. Not real good with my hashes. Sorry about that, folks. But if you look at your own graph, you will see that it's a 1 to 1. Like I said, if you look at the actual table drawn, it makes it more sense. All right, so that is all we're doing in 3.2. Remember the key terminology you're looking for here. We have linear and nonlinear. Linear, of course, means straight line. Nonlinear means it's still a function, but it's not a straight line. Whether or not it is discrete or continuous. Discrete means that it is dots that are not connected together, but still have to make a straight line. Very important. Still have to make a straight line. They're just dots not connected yet. Continuous, the dots are connected. They probably don't show any dots on there. It's just a straight line. It can either be a continuous line or it can be a segmented continuous line. All right. Questions? Remember, send me emails. Start the homework now while it's still fresh in your head. Good luck.